So here's a question that is asked. Someone on a forced choice test, a true-false test, gets 14 out of 25 correct. What is the probability that the score reflects chance performance? We don't have enough information to answer that question without knowing the probability of chance performance before the test begins. So probably the question that might be desired is actually what are the possible scores that you would expect to see in a 25 item true-false test when a person is guessing at the answer? That's a question that we can answer with the information given so far. And to do that, we would simply compute the standard deviation of a normal distribution or a binomial distribution, which is the square root of NPQ, where N is the number of test items and P and Q are 1/2 each. P plus Q is always equal to 1, and in this case the probability of a true response by guessing is equivalent to the probability of a false response by guessing. So our standard deviation is given by the square root of 25 times 1/2 times 1/2, which is the same as the square root of 25 times the square root of 1/2 times 1/2. The square root of 25 is 5. The square root of 1/2 times 1/2 is 1/2. So our standard deviation is 2.5. And we'll go look for a normal distribution calculator like this. And we're going to get the values from an area. We're going to set the area equal to 95. Our mean, our expected score by guessing on the test is 12.5, which is not possible, but we'll use it anyway here. So we want to know between what scores we would see 95% of the answers, and that will be some score bigger than 7 and some score less than 18. So our endpoints are going to be 8 to 17. Any scores outside that range are unusual, and with the standard alpha of 0.05, we would say that those scores did not occur by guessing. So I hope that's helpful. Thank you.